Hey guys, what's up? You're watching lesson number 3 of NoDev to GameDev, and today we're going to be learning how to write our first control structure, the if statement. After that, I'm going to teach you how to generate random numbers using a function you can find in the standard library. If statements in particular are really one of the core building blocks of logic in a computer program, and no matter what language you learn or what project you work on, you need to know if statements. So if you aren't interested in learning how to program, if you don't want to program anything in your life at all, feel free to click away. But if you really want to get something done, stick around and I promise you won't regret it. So what is an if statement? Well, basically an if statement is one example of a larger group of structures in programming called control structures, which basically just, they're blocks of code that control the flow of how the computer processes our program. To give you an example, in this lesson we're going to be learning about if statements, which are made out of two different chunks of code. The first part checks if some condition is true, and then if that condition is true, the second section will run a designated chunk of code. If that condition is not true, then the second section, that block of code, will not be run. If structures are used basically everywhere in games, from dealing damage only if your attack hits to running a particular chunk of code if, say, you're playing Pokemon and you throw a Pokeball. Well, if you made the hit chance, if you made the catch chance of the Pokemon, then the catch will succeed and it will run a certain set of code. And if it fails, if you don't manage to catch the Pokemon, then it'll run a different set of code. So that's basically where you'd see them used. So just next time you play a game, I want you to try and look for some examples of an if statement, because they're basically everywhere, and once you start looking for them, you're going to see them a lot more. Let's try writing some if statements for ourselves. In the last video, we created a player character and an enemy, as well as their health stats. I guess just their health stats. So I was getting a bit ahead of myself, but let's add attack variables, as well as some dodge chance variables. So they're both going to be integers, and the attack variable is basically just going to be the amount of damage we do every time our attack hits. The dodge chance variable will also be an integer, and it's just going to represent the percent chance that our attack will hit. So 50% chance to hit, basically. So with our variables declared, let's assign our attack to 1, and let's assign our dodge chance a value of 50 to signify that 50% dodge chance. Now at this point, we're ready to write the if statement that'll simulate an attack in a single turn of battle. So first thing what we're going to do is we're going to write if, and then parentheses, and then two braces. So as soon as you're seeing this, you're probably thinking, oh, that's just like printf, it's a function, and it's not. Control structures aren't functions, although they do have parentheses. That's just, it's more stuff you should know. It won't make a practical difference. But anyway, so in these parentheses, we're going to be putting the quote-unquote first part that I mentioned earlier, and that's the part that determines whether or not the statement will run. So in this demo, we're going to be using a chance to hit system, where the value that we randomly generate, if it's higher than the dodge chance, then it's going to hit, and if it's lower, it's not going to hit. So I'll show you how to produce random numbers later, but for now, what we're going to do is we're just going to write, say that we rolled a 51. So what we're going to do is we're going to write a 51 inside those parentheses. Then we'll put down a greater than sign, because according to our rule, what we roll needs to have a value greater than the enemy's dodge chance. And finally, we'll throw down our enemy character's chance to dodge. So here we have what we call our first predicate. Basically, a predicate is a type of statement that equates to either true or false. So I guess an example would be, ice cream is chocolate. True or false? Well, if it's chocolate ice cream, then ice cream is chocolate equates to true. Ice cream is chocolate, say it's vanilla, then ice cream is chocolate equates to false. And so that's just a basic example of a predicate in real life. But in programming, we have these predicates like our chance to hit, or our roll, is greater than our enemy's chance to dodge. So the way C actually goes about evaluating this predicate is it'll, just like with adding variables, it'll take the variable, the enemy dodge chance, it'll replace it with its value, so enemy dodge chance becomes 50, then we have 51 greater than 50, and that equates to true. So in C programs, the value 0 is equated with meaning false, while any other number equates to true. So we'll just say this 51 greater than 0 equates to 1, which is true. And so if true, it is true. So then the statement in the second part of our if statement will run. Now, before we move on, if you want to write any other predicates, there are a bunch of other symbols you can use. The greater than sign, the less than sign, greater than or equal to sign, less than or equal to sign, as well as the equal to sign. And I'm just going to have those on the screen there. You can try that with them, but I'm not going to use them in this tutorial just because we don't really need them yet. Alright, so now with the if function done, let's actually deal some damage to our enemy equal to our character's attack. So in other words, what we're going to write is basically a statement that assigns the enemy's health to be equal to the enemy's health minus our character's attack. And that'll look just like this, using the variables that we declared and assigned values to earlier. Now, so that we can see the results of our program, let's just copy and paste our printfs showing our character's stats to be after the if statement. If you take this program and then you compile it and then run it, you can see that both our character and our enemies started with full health, and that we dealt damage equal to our character's attack, and so our enemy lost health accordingly. So this is kind of cool because now we've actually begun our actual combat system, and you can see the game is sort of starting to take shape. But constantly rolling a 51 when your opponent has a 50% chance to dodge is a little lame. You know, that guaranteed success, we don't want to have that. So here I'm going to introduce a new function, rand. You can find rand in the stdlib.h library, which is, we call it standard lib or standard library. But the weird thing with rand is that we can't directly specify the boundaries of the random number generation by saying something simple, like put out a value between 1 and 100. The thing with rand is that it puts out a value between 0 and some very large constant cap that's sort of put in place by the programmers of the library. So we have to use a few little interesting techniques in order to have rand put out our percentage value between 1 and 100. So generally what we're looking to do is we're trying to have rand put out one number randomly from a range of different numbers. In this case, we're looking at a range of 100 numbers, the values from 1 to 100. And basically what we're trying to do is take a random number from that range. So what we do with rand is we'll modulus rand by the number of numbers in our range. So we have a range of 100 values. We're going to modulus rand by 100. And that will give us one value out of 0 to 99. Now, the reason this works, the reason why this will put out a value of 0 to 99, is if you'll recall with with modulus, it puts out the remainder of the division. So if a number divides perfectly by 100, the remainder will be 0. Say we get a random output of 2000. Well, 2000 divides perfectly with 100, and so we get a remainder of 0, even though 2000 is far outside of our range. Say we have the value 2001. Well, 2001 divided by 100 would have a remainder of 1. So now we have the modulus of that, which is the result would be 1. And that's also within our range. And you can keep going to higher numbers. Say we have the value 10,002. 10,002 divided by 100 divides perfectly except for a remainder of 2. So we take the remainder, and now we have an outputted value of 2. And so you can see this kind of works with all values, where the lowest output would be 0 if the number divides perfectly by 100, or 99 if it's the highest possible value that doesn't divide perfectly by 100. This trick doesn't get us all the way there though, because when we modulus rand by 100, we're still only going to be getting values between 0 and 99. But what we're looking for is values between 1 and 100. So the simple fix for this, it's much easier than the first trick. We just add the base value to the result of the modulus. So to clear that up, rand modulus 100, well, we want the base to be 1, so we add the value 1 to it. So then we have rand modulus 100 plus 1. And that basically shifts everything up by a value. if rand modulus 100 puts out a 0, well, we add the 1 and it's 1. So that's the new lowest value. And if it puts out 99, well, we add 1 to that. So now the new highest value is 100. And so say if you wanted to generate a number out of the group from 2 to 101, instead of adding 1 to rand modulus 100, you do rand modulus 100 plus 2. Now that shifts everything up by 2. But we just want it to be up by 1 so that we can get that nice 1 to 100 range. So we're just going to write that in there and get rand modulus 100 plus 1. Alright guys, so I hope you didn't get too confused by that. It was very wordy and sort of a little unintuitive maybe. But if you have any questions, you can always ask me in the comments section and I'll go through it with you until you understand. But I'm going to move on now, and we're going to have to start talking about how to set up this randomization, because it doesn't come pre-set up by the computer. First things first, I need to tell you a little bit about how randomization works on a computer. And that's basically the random function doesn't actually generate a truly random number. What it does is it takes in a seed value, and then it uses an algorithm to generate a set of numbers from that seed that appear random from the user's perspective, but it's actually just numbers generated from a very complicated equation. So the way we try to, make it seem even more random is we actually take a value, say the time at the computer as it's currently running, and we put that into the function. So whatever the current time is on the user's computer, that will be used as the seed. So you never get the same seed twice. And so the randomization function always generates a different set of numbers. Even if they're not truly random, they do appear random to the user. So let's set our seed now. To do that, what we have to do is call srand at the top of our program and pass it another function, which is time, and pass time the value null. So that's lots of functions being passed as parameters into other functions, but it's basically just going to look like what you see on the screen here, with srand and then time inside and then null inside that. What time does is it takes in a value, which in this case is null, and it puts out the amount of time that has passed since that value. Since we're passing the value null, it's going to go back and default to its default time, which is January 1st at midnight 1970, because we don't really have a specific time that we want to have our program counting from. We just need time to put out a value that the user can't predict. So once we have that value put out of time, it's going to be passed into srand, and then srand is going to be using that value as its seed. And just so our computer knows where we're getting the srand and rand functions from, we have to include them at the top, just the same way as we did with stdio.h. For time, we're going to have to include the time.h file, because that's where we get the time function from. And that'll just look like #include stdlib.h and #include time.h, both in angle brackets, just as you see it on the screen here. Alright guys, so there we have it. Now all we have to do is compile this thing and run it, just to make sure everything works. And so similar to as you saw before, we'll get our stats out before combat and then the stats after combat. But this will be a little bit different each time because of the random generation now. So sometimes your character might not hit, but sometimes your character might have hit. For the sake of our project as a whole, I want you to go into your code and after the character attacks, throw in a statement that calculates the damage of the enemy character dealing damage to the player character. And this way we're going to have one whole completed round of combat that we can expand on later. And then in addition to that, it's also, just good practice. I think it'll help really lock in everything that you learned today in this video. Alright guys, so that's about it for this video. We learned about if statements, predicates, and random number generation. And in the next video, we're going to be learning a lot about arrays, which are basically just like giant variables that hold many variables in one. They're super useful. I'm going to teach you all about that. But in the meantime, if you like this video, please like, subscribe, If you have any questions, you can ask them in the comments section. And if you want to see my code, it'll always be on GitHub. So I guess that's about it. Other than that, if you want to support this channel, please check out my affiliate link. It's in the description. Anything you buy there will support this channel. And that's about it. So thanks for watching. I'll see you in the next video.